Okay, here's the same circuit I had yesterday, except as promised, I removed all the direct connects to the LEDs. Now it's just 3 lines that go to this shift register right here, and that's what's connected to the LEDs. There's another shift register not being used for anything. Had some problem with resistance on this board, so I added some additional jumpers on both ends, but these little rails here, one's positive, one's negative, feeds off the 5-volt output on the Arduino over here. Yeah, 5-volt and ground. Luckily, there's 2 ground connections here. So for a source of voltage to measure, I have this little potentiometer hooked up like before. It will give 0 to 5 volts because one end is on the ground and one end is connected to 5 volts directly. So the middle will float in between there. So I will go ahead and start turning this thing and see what happens. 3, 4, yeah, just as before. I got rid of that delay, so it's much faster this time. Remember, these values multiplied by 10 and cranked all the way up. 49, 4.9. Close enough. Close enough to 5. If I take this potentiometer out down here and plug it straight in, it shows 50, so for 5. So, cool. Let's measure some real voltages and see what happens. See, I pulled the lines out of it to this potentiometer, and it's kind of going crazy. It's blinking all over the place, much like a inexpensive voltmeter when it's not connected to anything. The digits just kind of hop around all over the place. That's because it's picking up interference or whatever voltages out of the air. The best way to deal with this is just take a high value resistor and put it between the ground and the input pin, and once that's in place it will go to 0, and that's like a 500K or maybe 1 mega ohm resistor, so that's enough to keep it at close enough to 0 and bypass any sort of interference it's got. So I'll go ahead and hook up some leads and read some voltages now. Better, a quarter is a base. And as soon as I hook it up, it goes from picking up crazy interference to a set value, so that the first one is the 1s, 2s, 4s, 8s, 16s. Remember, it's multiplied by 10, so that's showing about 1.6 volts. I'm pretty happy with that. But I'll go ahead and stack 2 batteries up and see if I get something else. Sure enough, I stack up 2 batteries, and it registers the last digit, so 2 to the 6, that's 32. 3.2, it's twice 1.6. So these batteries have about 1.6 volts with no load each. And this voltmeter's working. Useful Arduino.